I'm Madison Nava, and today I'll be discussing scanning electron microscopy. So, what is a SEM EDX instrument? So, this instrument obtains elemental information as well as shows surface morphology of the sample. SEM generates X-rays for EDX detection. So, X-rays are produced when the electrons interact with the sample surface during SEM imaging. An EDX detector will detect these X-rays, then analyze and identify all elements in the sample. So, how are these X-rays generated? The electron beam will hit the inner shell of an atom, causing an electron to be knocked off from the shell. This leaves a positively charged electron hole. Another electron from an outer shell will fill the vacancy when the electron is gone. When the electron moves from the outer higher energy to the inner lower energy shell of the atom, there will be an energy difference. This is released in the form of an X-ray, which can be used to identify each element that exists in a sample. So X-rays are a fingerprint of each element. So, how does this instrument give us microscopic and elemental analysis? So, first, let's discuss them separately. So, the scanning electron microscope is best used to observe the surface morphology of a material, showing details, whereas the energy dispersive X ray spectroscopy, which is the EDX, analyzes the elemental composition of the material. So, SEM is connected to an EDX detector where X rays can be used as a signal to produce chemical information. SEM generates secondary electrons when the primary incident beam hits the sample, then ejects electrons from their shells. These secondary electrons produce topographic information about the sample. Backscattered electrons produce images with contrast that have information regarding the differences in the atomic number. So, sample types. Biological samples, including bodily fluids, tissues, cremains, etc. Explosives, such as the elements present in the explosive, type of explosive used, and its residue can all be analyzed using SEM EDX. Paint fragments can show, with this instrument, can show its surface morphology and determine its elemental composition. Glass fragments, gunshot residue, um, soil. Elemental analysis of soil can give an idea of the mineral composition, then relate it to a specific location. Sampling methods. So these are some sampling methods that can be used prior to analysis. So metallic stubs are highly conductive and used for various sample types. Non-conducting samples must be coated with a conducting material such as carbon, gold, or platinum. The coating must be ultra thin. Biological sample preparation includes fixation, sectioning, and staining. Mounting stabilizes the sample for excellent imaging. Drying techniques include critical point drying and freeze drying to eliminate solvents without damaging delicate samples. And then, of course, we have direct analysis. So let's get into a comparative study. So this comparative study that I'll be discussing is for real-time detection of gunshot residue particles from a crime scene. I4N LIBS is field equipment based on LIBS technology with the goal of guiding and facilitating collection of samples at crime scenes. So this comparative study analyzed gunshot residue particles and compared the analysis from the I4N LIBS and SEM EDX. And so let's first discuss what gunshot residue is. So, gunshot residue is comprised of particles composed of lead, barium, and antimony. with a spherical morphology. Why is this study important? Collection of gunshot residue can be pretty difficult when it comes to scenes that are in rooms, vehicles, or if the evidence is on multiple suspects. Random collections are ultimately performed by forensic scientists involving taking blind samples from all areas considered appropriate. The issue with this is that it creates a higher volume of evidence, which results in a waste of material resources and time when completing analysis. IFRN LIBS is the solution to this problem. So, as I mentioned, the sample that is analyzed is gunshot residue. There were a total of 135 samples analyzed using SEM EDX. 90 of these samples were classified based on the number of particles detected in each stub, which got subsequent analysis using IFRN LIBS. The advantages to this field instrument is that it has a low limit of detection. There is no need for sample preparation. It can perform direct analysis of any surface and it can identify and quantify elements in any physical condition. There were samples that were reanalyzed to assess the effect of laser ablation. There were 10 stubs discarded due to incorrect handling, and 5 stubs did not contain any gunshot residue particles. So, what were the results of this comparison? So, this table shows you different groups that were based on the quantity of gunshot residue particles from the SEM EDX analysis. And it also shows the number of samples in each group. So IFRN LIBS provided a positive result for all samples that held 3 or more characteristic gunshot residue particles. There were 5 false negatives because 2 out of the 3 elements got a positive outcome in a single LIBS pulse. The third element did not get detected because this particle was lower than 1 micrometer, which this instrument cannot detect. There were 6 false positives because of the presence of consistent or commonly associated particles in the same ablation spot or area. Reanalysis determined that to obtain a positive reading in all elements, the particle size must be greater than 1 micrometer. In addition to that, particles greater than 2 micrometers are not totally ablated and can be analyzed again by SEM or other techniques. So, the evaluation of this study. So, this comparative study showed that pre-analysis in the field would provide more information to the laboratory. Sample numbers can be reduced as valuable samples would be collected, which would help improvement of general results. So the study can be improved by analyzing gunshot residue particles on various organic and inorganic surfaces. In addition to that, maybe conducting a study using LIBS and a different type of spectroscopy technique. So definitely more studies for improvement would definitely be beneficial. The authors did a great job of using different scenarios and people to create a real life crime scene experience. I like how they reanalyzed samples and discussed it in the study. This made the study a lot more thorough. It was well written and very informative. And thank you.